Hi guys, I'm Ernest and this is Ernest Sciences and Mathematics TV channel. Today's discussion is basically going to be one of the members of the group for elements, and that is carbon. Now in this particular case, we're going to create emphasis on an emphasis on graphite, and the graphite is one of the allotropes of carbon, which we had mentioned basically among the other member of diamond, which we had listed. Now this is going to be having wide range of applications depending on the various requirements which we're going to see in our day-to-day needs. But of course, in terms of its structure, we are going to see some of the characteristics which are going to be creating convenience for its application. And of course, we're going to see that graphite is one of the, a part of the allotropes of carbon, which are going to be having high melting points and therefore withstanding, of course, high pressures and temperature, and therefore that is going to be giving it one of the characteristics of finding a wide range of application. Now, this form of carbon is going to be obtained mainly from coke, and of course, we're going to see that this is going to be the main source of graphite, and it's going to find wide application due to its excellent lubricating properties. Now, to mention the concept of van der Waals forces of attraction, which is going to be experienced by a number of atoms. And of course, graphite, as a member of the carbon, is going to be having these weak van der Waals forces. Van der Waals forces of attraction, which is going to be giving it these specific properties of a good lubricating, of course, a member of the carbon group. Now, of course, among this specific application for the lubricating, we're going to see that it's also being applied, especially in the as part of the stationery for the pencils that we use in writing. So the lead pencils, which we use in our day-to-day applications, of course, we can see their ability to slide on paper conveniently, and therefore that's going to be one of the ways in which we are going to see graphite being applied in this specific case. And of course, we are going to also see that one of the applications of this specific member of the carbon group is in industrial electrolysis, and this is going to be used in terms of course, electrodes in batteries in the process of the industrial electrolysis as electrodes in batteries. And this is going to be due to the ability of these specific members, as I said, to withstand high temperatures. Now, most of the electrolysis processes are being undertaken under high temperatures due to the requirement of this molten state, or the charge which is required in a molten state. And therefore, this is going to be one of the applications of this specific member of the group 4 elements. Now, it can be incorporated in some of the plastics which are used in making lightweight aircrafts. In plastics, to be making materials of lightweight aircrafts, and this is going to be providing a stable kind of a product, but in a sense which is going to be incorporated in a lighter elements, and therefore the need for lightweight. Now, in this specific case, also it's going to be used in tennis rackets. And now these rackets, due to the impact that is required during their application, of course, they are going to be required to be tough in nature, and therefore this specific element is going to be required in its specific application for them to be tough to meet the requirement. Now, in our next illustration, I'm going to use a phase diagram for carbon, and that is going to be assisting us appreciate the variation of various thermodynamic variables of temperature, perhaps, and pressure, which are going to assist us try to see different forms of a carbon in terms of a phase diagram. Now, in this particular case, it's going to assist us appreciate some of the ways in which we can vary these variables in order to obtain various forms of a diamond, and that is going to assist us in appreciating some of its applications. Now, the above is a phase diagram for carbon, and we're going to use this in appreciating the various forms which can be obtained from a variation of a temperature and the pressure. And of course, we're going to see that at this specific point, this value of approximately 3000 being given at this particular point. And of course, this is going to be in terms of degrees Celsius given as such. And this is going to be pressure in atmospheres. And therefore, at the point of around 3000 degrees Celsius and pressure over 10 raised to, so I'm going to give this specific value. So in this particular case, we're going to see that for us to obtain the phase of course, a diamond from graphite, we're going to have to look at these specific conditions, whereby we're going to see that particularly for this one, we're going to just be following this specific graph that is going to illustrate basically at the phase, and therefore this specific point of approximately 3000 degrees centigrade and a pressure of around 10 to power 4. So this basically we can write it in standard form. So the pressure of 10 to power 4 atmospheres and the temperature beyond 3000 degrees centigrade, we are going to obtain diamond from graphite. And this is one of the ways in which we can vary different forms or phases of these specific forms of carbon through varying these two variables of pressure and temperature in order to obtain these forms of diamond and graphite, perhaps in vapor, liquid, or diamond or graphite form. Now, I mentioned that graphite is going to be the most stable form of this carbon, and this is because it's going to be one of the forms which are going to withstand a high range of temperatures. Now, in this case, we can as well see that if you want to obtain perhaps a diamond from these specific or different types of metals, we're going to mix graphite with the metal such as iron, and then we are going to expose this one to high temperature, and the graphite is going to be converted into diamond, and of course this upon liquefaction can be separated from these forms of diamond. Now in our various discussion, we're going to come across other allotropes. Now I mentioned the concept of isotopes, so we're going to come across other forms of carbon in terms of allotropes, and these are going to be referred to as fluorines. So I hope my pronunciation is right. You can kindly confirm on this. So they are referred to as fluorines, which are going to be allotropes of carbon. And this, of course, are going to be can be illustrated in forms of carbon with those specific numbers. So we're going to have carbon 60, carbon 70, carbon 74, and perhaps carbon 81. And these are going to be especially be mentioned in various applications, especially when we're going to look at some of the applications of these elements in nanotechnology. Now, in this specific case, then therefore, this is a short summary of some of the applications of graphite and some of the characteristics in terms of these specific forms, in terms of phases, and of course some of the allotropes which we are going to come across over carbon. Now, some forms of carbon may appear in terms of a soot, of course, which we experience in our day-to-day lives, and of course we are also going to mention some of the characteristics in terms of its application, which are widely mentioned, especially under the concept of organic chemistry. So kindly check our description boxes for various links of other videos, and subscribe to our channel so that we can be getting updates on various discussion we do in maths and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.